So this is a bonus lecture on research design. Research design is sort of how you lay out an experiment. And oftentimes it's not actually part of statistics in an intro course. Statistics is kind of learning about probability and variation, and you use different statistics depending on your research design. But you want to know about research design, trust me. So I'm gonna tell you about it right now. It's a bonus. So research design, experiments typically have a predefined structure. If you look at a journal article under the methods section, you will find it'll sort of go subjects or participants, design, procedure, and so forth. The design is the logic of the experiment. And so there's lots of language that's very useful for describing experiments. And so I thought I would give you the language for the study that we were all in, the generation effect study. As a reminder, in this study, people saw word pairs in one of two primary conditions. One condition was the read condition, and so you'd see a pair of words and you just had to read them, so you'd go fast, rapid. In the second, the generate condition, we would leave words out, and you had to figure out what that second word was and then read it. And you can do this pretty quickly. They weren't meant to be puzzles, but you had to do a little work to figure it out. And then after a delay, you tried to free recall the words. That means that you didn't recognize whether you saw them. You just had to remember them and write them down. So that's called a free recall. So the design of this experiment, it's a factorial experiment, and it had 3 factors. And within a factor, there are levels. So word relation was a factor, and it had 3 levels: synonym, antonym, and rhymes, right? And so you could have fast, rapid, or fast, slow, or fast, past, right? And so the second word would either be a synonym, an antonym, or a rhyme, and you knew that. You knew what you were supposed to be doing. And so those are the 3 levels of the word relation. There was the word position, which was whether you remembered the first or the second word. And then the task itself had 2 levels, which was read and generate. So the 3 factors were crossed to make anybody, a 3 by 2 by 2 research design. So let me show you what that looks like. It's good to lay these things out. It seems like who needs to make a visualization? You got it in your head, but it's surprising how it helps to sort of lay it out and make it square. So you have your word relation factor that has 3 levels, and that is crossed with your task factor, read and generate. So you did read for all 3 types of word relation, and you did generate for all 3 types of word relation. Then there was a third factor, which is sort of a pest to represent in this format, which is word position, whether you saw it as first or second. And so I've just sort of written it in there like that. But the way you want to think about it is I'm going to show you, but the way you think about it's kind of really a bad way to draw it. So this is a better way to draw it. Here's the way to think about it. It's really sort of a cube of 3 dimensions. Each factor is a dimension. So one dimension is this one. Another dimension is this one, and another dimension is this one. And so you can see you've crossed all 3 factors. And so crossing them gives you 12 cells, right? So it's 3 times 2 times 2, which gives you 12. The cells are very specific. So this cell is, you're in the rhyme condition, you have to generate, and we're looking at memory for the second word, not the first. This cell back here is where we're in the rhyme condition, you read the second word, and we want to see your memory for the first word. So there's 12 of those altogether. So the next kind of language has to do with results. And so you can talk about main effects, and this is kind of the big level effects. So I'm going to simplify the world and get rid of the word order factor, which is just hard to draw on the screen. So I'm going to make life easier, and it's going to look like a 3 by 2 instead of a 3 by 2 by 2. So over here, I can write, I need to remind you, these are not the data that you received. These are from a different class. So they could have different numbers than the data you worked with. So that's good to know in case you don't suddenly get really upset at what's going on. So over here, this is called the marginal mean. So the 0.80 is the average for the average number of words you remembered in each cell of the read condition. And the 1.07 is the average you remembered for each cell in the generate condition. It's a lot of words. You'll see what that means in a second. But just remember, it's the average. And so going down this way on the columns, we can see the average performance for synonyms, antonyms, and rhymes. So if I just compare these values on the right, these are called marginal means. So remember that. Sorry about that. But if I pause and you have to hear me make up for it, you'll remember it better. These are the marginal means. So over here on the right, these are called main effects. I'm comparing the two levels of the task factor. And I don't really care whether it's synonym, antonym, or rhyme, or first or second. I'm saying on average, does generate beat read? And so if you look at it, it looks like it does, right? So that's a main effective task. I can do the same thing along the bottom, where I can say, is there a main effective word relation, regardless of whether you're reading or generate? So the next thing we want to do is say, well, what were the actual values in these cell means? So here for synonym, you can see if you read a synonym, you remembered about 0.63 of those words. And if you generated a synonym, you remembered 1.04. It's the average of these two values that gives you this marginal mean. So the marginal mean is the average value in each cell. And so I can do this for each one. And then we'll do it for rhyme. So you should look at this for a second and decide, is there really a main effective generate? Does generate always work, regardless of what kind of words you're dealing with? The answer is no, not in this case. So here, if you look at the yellow arrows, you can see that generate is doing better. But if you look at the red arrow, you can see that read does better. So for rhymes, it's better to read than to try and generate if you want to remember the rhymed word. So this flip-flop like this, where not everything's behaving the same, is called an interaction. And so the interaction is that the effect of the task, read versus generate, depends on the type of word relation. You just can't say generating is always better. Generating is conditionalized. Its effect depends on what kinds of words you're dealing with. So interactions are sort of a lot in your head to hang on to. And so it's good to sort of get used to them. So your graphs really take advantage of the factorial design. And so you can see how this language works for how you used it. A lot of your graphs could be classified as exploring main effects. So you might have made a bar chart that showed the average for read versus the average for generate. Or you might have shown a chart that showed memory for the first word versus the second. Or you might have done one for synonyms versus opposites, or that should be A for antonyms versus rhymes. So those were comparing main effects, because you're just looking at one factor and comparing the levels of that factor. Then there were slides that were more ambitious. They were looking at two-way interaction. So you're looking at two factors. You have read versus generate crossed with the type of word relation. Or you might have shown read versus generate crossed by first and second word. So there you sort of compare it. You're getting four different values. How well did read do for the first word? How well did read do for the second word? How well did generate do for the first word? How well did generate do for the second word? And so on. And then there are the three-way interactions, or in this case there's only one possible, where you're actually looking at all 12 cells of the design simultaneously and trying to say, are there patterns that are more complicated than what the main effects and the two-way interaction show? Of course, there's also the gender factor, which everybody always likes. And so this creates a 3 by 2 by 2 by 2 design. I think that was right. There should be 3 2s in there. And so that they get very complicated. So one last word language that you need to learn that's important for experimental design is in this study, each factor is within subjects. That means that each subject completes each level of the experiment. Each subject did all 12 cells. And so this is completely within subjects, and you're comparing people to themselves, right? And so there's a lot of reasons this is a very good research design if you can pull it off. Sometimes you can't. Sometimes people can't be in both conditions simultaneously like they could here. Or, as in the case of this experiment, a lot of you like the between subjects factor that was not part of the research design, but was gender. And here you're comparing differences between people. So it's between subjects where you're looking for differences, not within subjects. If you include it, it's the 3 by 2 by 2 by 2. So you can keep adding factors, and it's kind of a rookie mistake when you design your first experiment that you start to think of all the things that can make a difference, and you add them as a factor. And you get sort of a 3 by 2 by 2 by 2 by 5 by 3. And these become more complex than any mortal person can understand in finite amount of time. So it's good to resist and stay simple. You do a simple experiment to start with, and if it works, then you get a little more complicated. 2 by 2 is my particular favorite. It's as simple, but the interaction's very useful to try and find those. Okay, keywords. Here they are. These are the words you should know. And you can come back to these and study them if you'd like, or not. So now, what I'm going to do is I'm giving you an assignment. And I'm going to give you a slide that describes an experiment, and then another slide that shows the results. And you have a set of questions, and you should answer those questions in the course management system. This should be easy. It's just a chance to practice. You should feel free to look back at the earlier presentation if you're not sure about the language and so forth. So here's the description of the experiment. I'm going to let you read this. I'm going to leave it up for just a few seconds here so you can pause the video to look at it longer. And then in a few seconds, I'm going to switch to the next slide. And that really was a few seconds, so you couldn't read all of it. The next slide, this shows the results from the study, and it shows the questions that you'll need to answer in the online platform. So you can go back and look at these slides all you want. You are now research design experts. You know the main language, so your life is going to be very, very improved. And that's why this was a bonus lecture. Thank you.